In the last class, we discussed about accelerometers and particularly how they are used for vibration measurements along with eddy current, proximity probe and so on. Well, today we will discuss in this class about vibration monitoring. As you know, 70% of the cases of machinery condition monitoring are done through vibration measurements and monitoring. So, we will see what are the real issues when one goes to measure or monitor vibrations of machine. So, this monitoring, as I had told you right in the beginning, can be two methods. One is offline and another is online. So, in offline monitoring, what we have permanently mounted transducers. Okay. Offline, they could be permanent, but data analysis is done at a later date. So, for critical machines, one has to do online monitoring, because in real time one gets to understand what is the condition of the machine component. For example, though we have not studied bearings, I will just tell you a fact now. See, as you know, machines have rotating shafts which are supported on bearings, okay, and then similarly on this side. So, what happens? These bearings, those of you who know about ball bearings, they have a layer of lubrication. So, if the bearing temperature increases because of friction, this lubrication may get baked and they will form hard particles which will score the races of the bearings and eventually damage the bearing. So, to avoid this not to happen, or to avoid that this temperature rise does not occur, always in industry the temperature of bearing is monitored. And usually the industry practices, many industries have it, it has to be less than 62 degrees Celsius, somewhere around 60 to 70 degrees Celsius, and beyond 70 degrees Celsius it is an alarm level, alarming conditions. So, this was just to give you an example. Suppose we are doing online monitoring of any parameter, there are certain target values which has been set. So, these parameters, it could be like, what do I mean by parameters? It could be the time domain features of the signal, like the RMS value, the mean value, the peak value, etc. Okay. Or even kurtosis. We all know about this right now. So, any signal which has been captured online and analyzed and its parameters determined, we can set preset conditions that this is the alarm level, and I would not let the parameter which I am measuring go up to this point. So, then it will either ensure certain safeguard measures like stop the machine, or give a warning sign to the operator that this machine needs to be fixed. So, these are the cases where online monitoring is being done and the measured data is compared or targeted against a set value, and depending on the conditions, a machine could be stopped, an alarm could be given, and so on. So, in vibration monitoring, actually what happens when we have online monitoring, offline monitoring, people, depending on the criticality of the machine, somebody may do an online monitoring and offline monitoring. But if you see the industrial scenario of vibration monitoring, for example, this is a part of a cement plant wherein this is the torsion shaft which is being driven from a speed reduced gearbox, and there is a pinion gear here which is meshed with the ring gear of the kiln. So, if I was to draw this one view which is rotating about 3 rpm, very slow rpm, and this diameter is about maybe 3 meter. Okay. And so, if this is rotating, there is a set of gear, and of course, these are all supported on bearings, saddles. So, if I have a ring gear all around it, and onto this I put a pinion gear which is driven by a, this is put in a bearing, long bearing, and then there could be a gearbox which is being driven by a motor. So, this is my gearbox, motor, torsion shaft, the weak structural member here, and then this is the pinion gear and the ring gear or the bull gear as it is known. So, what happens, this raw material is put and there is a gradient here, this drum slowly rotates, and then they are ground by grinding media which is kept in the shell, and then the dry cement comes out. But the question here is, you can understand the complexity of such operations if somebody was going to do monitoring of this in situ, because this is very dusty. This environment is very dusty, and we cannot be sitting there and doing an analysis. So, if you will see here, while we are doing this monitoring, we had put an accelerometer on the bearing housing supporting the pin gear, and then this accelerometer cables, if you see here, are being taken, and then usually measurements from the field or field data are recorded, and we did discuss about DAT tapes or even nowadays DVDs, and then they will come to the station where analysis could be done. And this is why did we record it? Because the environment is not conducive enough, not comfortable enough for anybody to do any serious analysis. This is one aspect of doing it, and this was monitored by what is known as an contact based measurements. And when we talked about contact based measurements, these accelerometers have a mass, some mass. Now, imagine if I am measuring the vibration of a very thin structure, and if I put a heavy transducer of some mass n, the transducer mass is going to affect the dynamics. So, I have loading the transducers, loading the system. So, I must have an accelerometer which is less than, much less than 1/10 the original mass of the system where I am measuring vibrations. Okay. But then this is always not possible for light structures. Okay. So, for light structures we need to have non-contact based transducers for vibrating monitoring, and this is actually done by what is known as laser based measurements. So, how does this laser based measurements work? Let me just briefly explain to you. You all know what is this Doppler effect. That means, if I have a source, structure which is vibrating. Okay. If I shoot a laser beam with a V, okay, Fs by C plus Vs is Fl by C plus Vl. Okay. So, what happens if I am sending a laser beam? Because of these vibrations, it is going to get reflected back. Now, this frequency shift, because of the vibration of the source or whatever you call it. Okay. Of course, you have to make sure that the right sign conventions are there. I am not going to the details of the sign convention here, but in essence what happens if I shoot a high light beam, laser beam onto a surface which is vibrating with a velocity V s, I will get a frequency of the laser beam reflected back F L, which is related by this equation, and then by knowing the difference F s minus F L, okay, I can measure this. How do I do it? There are optical heterodyning measures, because as you know by now, laser beams are light waves of very high frequencies, and obviously to find out the frequency shift we need to have what is known as signal heterodyning. So, just to recap these things which we had discussed earlier. So, signal heterodyning is used to find out the frequency of the reflected wave, okay, by and then we can find out the source vibration of this velocity, vibration of this body which is vibrating and whose vibration we need to measure. Such laser based measurements can be used both for linear vibration and for rotational vibration, and also we will see. So, if you see, for rotational vibration meter, I had talked about rotational vibration, and of course, there is another very easy way which we have done some work at IIT Kharagpur on optical encoders. By the way, to know more about some of these, you can visit my website www.iitnoise.com, and in my Google Scholar you will see some of the literatures on the how rotary optical encoders have been used to measure the rotational speeds of engines, to find out the firing frequency of engines and so on. But today here we will focus more on the linear vibration measurements and rotational vibration measurements by lasers. So, you see this is a single point laser which is being used to measure the vibration of a compressor of a refrigerator. Imagine if this compressor is very small. Of course, compressor because of its operation there will be a lot of heat generation. This surface, many of you would have felt in your domestic refrigerators that the compressor shell is very hot and it is not desirable to touch it. Of course, today we have charge accelerometers which can be put on such compressors to measure the vibration, but this being a light shell structure, the accelerometer which we put here may load the structure. So, this is a laser vibrometer being focused onto a surface wherein the laser beam is reflected, and some things I must tell you, many surfaces are very dull. So, they will not reflect a laser light. So, what they do, people put reflective patches. So that you will get a reflected laser light back, and then we can measure through signal heterodyning optically the frequency shift, Doppler shift, and then find out the velocity at which this shell is vibrating. Now, I have two laser beams. Okay. I have a laser beam A, laser beam B, and this is the principle behind the working of a rotational laser vibrometer. So, if this is a shaft onto which it is these laser beams are focused with a separation distance of d. For this separation distance, they have to be identical, okay, because the signal to strength should be balanced, and so I will have a reflected and component here V B and V A and so on. And by this equation, you will see that the Doppler frequency shift, which is measured in the heterodyne analyzer, is a function of the rotational speed of the shaft and the separation distance and the wavelength of the laser beam. So, anywhere if I shoot two laser beams onto the rotating shaft, I can find out this omega. The best part about this rotational laser vibrometer is, and also for the linear vibration measure, is I can shoot or measure from large distances. Imagine you have to measure the vibration on top of a large tower. It could be a transmission tower, it could be a windmill, etc. And you are standing here. Obviously, in such cases, okay, one is not. So, you can have a laser beam and shoot and reflect back. Of course, today, let me tell you the technology, you all must be hearing about drones. People have started to use drones for, obviously, for visual inspection, and the drones could carry lasers, could carry thermal imaging camera, to measure at locations where humanly it is time consuming, it is dangerous, and so on. If you look into or see in North Sea, okay, in the above Europe and between Germany and UK in the North Sea or in Denmark areas, you will see in the ocean there are a lot of wind turbines being put, or they are in place. So, it is a challenge to measure or monitor the condition of the gearboxes, etc., of these wind turbines. So, traditionally they go by helicopter, and you have to be a very skillful operator or pilot of the helicopter to place the equipment below or drop somebody there to go and inspect visually. So, these are all very time consuming, dangerous, and this technology now, and of course, later on I will tell you of another technique, which is motor current signature analysis. By that, how remotely we can also monitor the conditions of the machine without even actually physically going there or touching them or contacting them. So, to summarize, we could use drones having cameras for visual inspection, having lasers for vibration based measurements, or having thermal imaging camera for the heat temperature detection. And then of course, I can have a motor current signature analysis where I can monitor the current. Okay. So, one thing about the lasers is the focusing distance. Okay. Sometimes this is known as the standoff distance, and the beam separation. So, this is a view in our laboratory. If you will see here, this is a shaft, and if you can see here, there are actually two laser beams. I somehow in this diagram we are not able to see it, maybe in another diagram. So, this is the laser head where laser vibrometer is being put, and there is a lot of signal conditioning be required, and you will get either the entire time series of this wave, this velocity, and which you can later on do any analysis. Yeah. And here if you see the zoom picture here, you will see two dots. This corresponds to those two laser beams which are being put on the shaft. So, you can very easily measure the speed, and actually in many condition monitoring it is not the mean speed, it is the fluctuation speed. Okay. And this fluctuating frequency are because of the load torque, which is because of the defects. I say defects or any conditions, any conditions. If I change the load on the system, I will be coming out with a different frequency. So, obviously, momentarily the shaft which is rotating will have a change in its speed. This is not equal to the mean speed, which you would measure with a tachometer, etc. Okay, we will talk about these later on. So, it is these kind of conditions which help us by using rotational laser vibrometer to find out the defect frequencies in systems. This is another view of the rotational laser vibrometer. And these systems are very expensive compared to the traditional linear based vibration measurements using accelerometers or optical encoders. Nevertheless, they are advantageous because they are non-contacting and you can measure them from a distance. Now, I did mention in your earlier classes that what is the limit of these vibration levels and why at all we measure these vibrations. One, of course, is to find out the defects in machine by the signature analysis of the measured vibrations. But even I must tell you, if you are making a product or designing a product or developing a product, like for example, even the steering wheel of an automobile which has been designed, okay, or even the rear view mirror which is being put in an automobile, okay, steering wheel. So, this is your rear view mirror, this is your steering wheel. So, a designer would have done a good job, but imagine if somebody was holding the steering wheel and it always vibrated. Okay. I will give you another example is this, people doing jackhammering. So, persons are holding on to certain devices, handheld measuring equipment, portable power tools like drills, grinders, saws, jackhammers. Now, imagine again if your rear view mirror always shook while you are driving the car, it would be very difficult, annoying for a person who is trying to focus on the rear view mirror, but the mirror is shaking because of a bad isolation and so on. So, there are limits as to, because if you are exposed, your body or arms are exposed to high levels of vibrations, you will have a nervous disorder. So, there are ISO standards as to what are the frequencies and what is the hour or time to which you can be subjected to the maximum levels of vibration in particular directions. So, today there are essentially vibration based transducers which are used or available for measuring this equipment vibration, and then one has to be careful about it. So, this is one work which we did. I thought I must share with you that in some company they had a tractor. As soon as the tractor engine idled, there was excessive vibration, and then later on we realized through analysis that the natural frequency of the steering wheel actually matched to the one of the engine firing frequencies during the idling. So, of course, we could not change the engine. So, what we did is, through analysis, we shifted the natural frequency of the design of the steering wheel, and thus shifted the natural frequency and avoided the condition of resonance, so that the vibration level reduced. And this is the example of that same tractor which has been used for the measurements. Of course, when I talked about vibration based measurements, of course, in the next class we will be talking about rotational speed measurements, but then we will discuss more of this in detail later on. But this is just in an industrial system where the the optical tachometers are being used for measuring the speed. And in industry, many times people will not allow you to put anything, a tap onto their surface. So, usually I put a pre-tapped block of aluminum on, and then I just glue them there, and then I mount my accelerometers for measurements. This is the bolt head onto which I have glued my block, onto which I have screwed this triaxial accelerometer. So, this is a good practice to have in your kit when you are going to do vibration based measurements, to carry some of these mounting blocks with you. They are very easy to make, but only thing you have to make sure that the surfaces are nicely machined. So, there is an ISO 10816 standards, okay, people can look up to. So, the vibration level is measured in RMS. The frequency range is from 10 to 1000 hertz. Vibration level is measured in the velocity mode. There are 3 different levels of this overall RMS vibration level, depending on the power of the machine, which is given in this ISO standard. So, people can know whether my machine is acceptable, not acceptable, requires immediate maintenance by this. For example, a good thumb rule is for a 1000 kilowatt machine, the vibration level of the RMS velocity should be less than 3 millimeters per second. These are some of the locations where we need to put the transducers, because everybody needs to know where do I put the transducer when I am doing a vibration monitoring. It is usually the bearing locations or the foundation locations, and so on. I will discuss more of this in the next class. Okay? And these are some of the examples in gearboxes, in conveyor system where we are measuring vibrations. And just to give you a view, ship loading raw material into a conveyor system, and there is a loaders here, crane operated, so they can scoop from the hull of the ship or drop into the hull of the ship. But these are these conveying systems. Imagine if these are not monitored, if there is a problem with the conveying system, your ship is not able to either load or unload, it will create a lot of ripple effect, because other ships cannot come into the jetty and so on. So, you can understand the severity of the problem, and imagine in our country, if we are importing coal, good quality coal, exporting iron ore, and if our ports get blocked because or somebody did not do a good job in monitoring the vibration levels of a conveyor system, what kind of disastrous consequences it can have in our economy. So, you can understand the importance of vibration monitoring and so on. This is a permanently monitored transducer. This is all the steel cabling which you see for vibration monitoring in a paper mill, rolling bearing vibration monitoring. Sometimes speed measurements are being done, which I will discuss in the next class. And then of course, you can have a control room wherein everything comes onto a GUI, and an operator nowadays does not have to go to a machine individually, but then these are the junction boxes. He can just monitor any machines he wants, and today the state of the art is that they will even, the signals will even come to your mobile apps. And this is where we are doing also the gas turbine monitoring and so on. So, more of this you will see some of the case studies in my book on machinery condition monitoring. Thank you.